Marvel will deliver an extreme-scale corpus of processed multimodal audiovisual data, obtained free of charge and released as a service, in order to address the lack of extremely large public sets of annotated audiovisual recordings. In order to do that, a distributed storage system has been deployed using state-of-the-art technologies for holding processed multimodal audiovisual data. The technologies that have been used are the HBase and Hadoop open-source frameworks. As you can see in the screen below, all individual components of HBase and Hadoop are delivered as separate containers, connected to the same network, including a Hadoop master node, a zookeeper that manages the HBase and several region nodes where data is distributed. Furthermore, Apache Ampari through its RESTful APIs will be used to perform queries to the data repository, while a novel graphical user interface has been developed along with relative APIs providing to the user of data corpus the ability to add, view and delete data to the latter. Graphical user interface of data corpus as a service. Data management of data corpus is obtained via a novel graphical user interface that has been developed for that reason. The graphical user interface on its landing page shows an overview of the stored data in the corpus, including the total number of datasets, the type of datasets that has been stored and the number of datasets per provider. By pressing the Add button, a new page is emerged, where the user can add a dataset by providing a series of mandatory fields, such as the name of the data provider, the use case in which the dataset refers to, a series of keywords, a general description of the dataset, the status and the category of the dataset. For each dataset that is injected to the corpus, the user also needs to fill in the metadata fields of the dataset such as video resolution and FPS, in case of video data, or bit rate and sampling, in case of audio data. Furthermore, user has the ability to provide additional metadata information, depending on the nature of the dataset, including the annotation ontology and software that has been used, the location longitude and latitude of the recording, if the dataset is annotated, augmented or anonymized following the augmentation and anonymization method. Finally, the user, per dataset, can upload to the corpus a number of snippets referring to the specific dataset, providing the publication date of the snippet, the duration, the start and end time of the snippet, the timestamp of the snippet, additional events and the annotator identification and summary. Then the user, for each snippet, can upload the corresponding annotation file, the interference result file and the snippet file to the data corpus. By pressing the Add button, the dataset along with the relative information and snippet files are uploaded to the data corpus. Returning to the landing page of the user interface, the user has also the ability to view, delete and update any dataset that has been uploaded to the corpus, while an alternative tab, namely Snippets, will present information about the snippets per dataset if any. Continuous augmentation of the dataset. STS developed several Python audio-video augmentation scripts using Keras, TensorFlow and ImageO libraries. In terms of video augmentation, a series of augmenters such as brightness changeness, noise addition, rain effect addition and geometric transformation has been used, while in terms of audio augmentation, white noise addition and random gain augmentators, has been used among others. These augmentation scripts currently running in the data corpus produced several augmented files based on the original recordings. A sample of produced augmented video files along with the original recordings are presented on the respectively screen.